Welcome to Maths for Matrics, South Africa's #1 destination for Grade 12 mathematics. Today's lesson is about geometric sequences, under the topic Sequences and Series, on the Grade 12, CAPS, syllabus. Please be aware that this channel only focuses on pure mathematics and not mathematical literacy. If this video helped you out, please leave a like, and subscribe so that you never miss an upload. And be sure to spread the word about this channel so that we can help as many grade 12s as possible. So, let's get started. What is a geometric sequence? A sequence is geometric if the ratios of its consecutive terms are equal. Now, let's go into details. A sequence is geometric if t2 divided by t1 is equal to t3 divided by t2 and is also equal to t4 divided by t3, including the ratios of all the consecutive terms in between, is equal to r, where r is not equal to 0. The number r is called the common ratio of a geometric sequence. The general term of a geometric sequence. The general term of a geometric sequence is given by the formula, Tn is equal to a times r to the power of n minus 1. Now, let's break this formula down. If a is the first term of the sequence, and the second term is equal to a times r, then term number 3 will be equal to a times r squared. And if you continue the pattern by continually adding 1 to the term number, whilst multiplying by r on the other side of the equation, you will come to the conclusion that the power of r is equal to the term number minus 1. Therefore you can generally say that the nth term of a geometric sequence is given by Tn is equal to a times r to the power n minus 1, where a is the first term of the sequence. And r is Tn plus 1 divided by Tn, where Tn is not equal to 0. Now let's do some exercises. Exercise number 1. 5, 20, and 80 are the first three terms of a geometric sequence. Find the value of the 10th term of the sequence. In order for us to solve this problem, we need to first find the nth term of the sequence. And to do that, we need the value of a and r. We already know that a is the first term, and the first term of the sequence is 5. Therefore a is equal to 5. R is equal to term number 2 divided by term number 1. 20 is term number 2, and 5 is term number 1. 20 divided by 5 is 4. Therefore r is equal to 4. The nth term of a geometric sequence is given by Tn is equal to a times r to the power of n minus 1. Now, let's substitute our a and r into the formula. And now that we have our nth term, we can go ahead and find the value of the 10th term of the sequence. Term number 10 is equal to 5 times 4 to the power of 10 minus 1. 10 minus 1 is 9. 4 to the power of 9 is 262,144. And 5 times 262,144 is 1,310,720. Therefore, term number 10 is equal to 1,310,720. Exercise number 2. The second term of a geometric sequence is 16, and the fifth term, is 8192. 2.1. Write an expression for the nth term of the sequence. As we have established in the previous exercise, there are two things that we need in order to find the nth term of a geometric sequence. And they are the values of a and r. But this time, we are given the value of t2, the second term of the sequence, and the value of t5, the fifth term. So how do we find the values of a and r? I am going to show you two methods of finding them when you have this kind of problem. The first one is solving for a and r simultaneously. We know from the general term that the second term of the sequence, t2, is equal to a times r. The value of t2 is 16, so we can go ahead and substitute t2 with 16. If we divide both sides by r, these two r's cancel each other. We now have a is equal to 16 divided by r as equation number 1. We also know that the fifth term, t5, is equal to a times r to the power of 4. Let's substitute t5 with its value, 8192, and call this equation number 2. Now, let's substitute equation 1 into equation 2. Looking at this equation, this r and one of these r's cancel each other. We now have 16r cubed is equal to 8192. If we divide both sides by 16, these two 16s cancel each other. And 8192 divided by 16 is equal to 512. Therefore, r cubed is equal to 512. Now to find the value of r, we have to evaluate the cube root of both sides of the equation. We are now left with r is equal to the cube root of 512. The cube root of 512 is 8. Therefore, r is equal to 8. Now that we have our r, we can go ahead and substitute it into equation 1. 8 goes into 16 two times. Therefore, a is equal to 2. I am now going to show you another method for finding the values of a and r. In this method we look at the relationship between the two given terms. We are given the values of t2 and t5. So, t5 is equal to t2 times r cubed. In this method, the power of r is always equal to the difference between the two terms. 5 minus 2 is 3, therefore the power of r is equal to 3. t5 is 8192, and t2 is 16. Let's go ahead and substitute them into the equation. If we divide both sides by 16, these two 16s cancel each other. 8192 divided by 16 is equal to 512. Therefore, r cubed is equal to 512. R is equal to the cube root of 512. And the cube root of 512 is equal to 8. Therefore, r is equal to 8. From the definition of the general term, t2 is equal to a times r. t2 is 16, and r is 8. If we divide both sides by 8, these two 8s cancel each other. And 8 goes into 16, two times. Therefore a is equal to 2. Now that we have our a and r, we can go ahead and write the expression of the nth term of the sequence. Tn is equal to a times r to the power of n minus 1. Let's substitute our a and r into the formula. Now looking at this general term, we can see that it is not in its simplest form. Because 2 cubed is equal to 8, we can rewrite it as 2 times 2 cubed in brackets to the power of n-1. Now let's multiply the n-1 into the brackets. If you multiply expressions of the same base, you add the exponents. And if an expression doesn't have an exponent, its exponent is equal to 1. Therefore, Tn is equal to 2 to the power of 3n minus 2. (2.2). Find the value of term number 7. Now that we have the general term of the sequence, we can easily find the value of term number 7. Our general term is Tn is equal to 2 to the power of 3n minus 2. Term number 7 is equal to 2 to the power of 3 times 7 minus 2. 3 times 7 is 21. And 21 minus 2 is 19. 2 to the power of 19 is equal to 524,288. Therefore, term number 7 is equal to 524,288. (2.3). Which term in the sequence is equal to 1024? In order for us to solve this problem, we have to substitute Tn with the given value of the term we are looking for. Our nth term is Tn is equal to 2 to the power of 3n minus 2. The value given to us is 1024. So 2 to the power of 3n minus 2 is equal to 1024. 2 to the power of 10 is equal to 1024. Therefore, 2 to the power of 3n minus 2 is equal to 2 to the power of 10. We can now simply drop the base on both sides of the equation because they are similar. Now we are left with 3n minus 2 is equal to 10. If we add 2 to both sides of the equation, we have 3n is equal to 12. We can now divide both sides of the equation by 3. And if we do that, these two 3's cancel each other. 3 goes into 12 4 times. So, n is equal to 4. Therefore, term number 4 is equal to 1024. Exercise number 3. X minus 1, x plus 1, and 2x plus 2 are the first three terms of a geometric sequence. Find the value of x, and write down the values of the given terms. In order for us to solve this problem, we need to remember the definition of geometric sequences. And it states that a sequence is geometric if the ratios of its consecutive terms are equal. The common ratio r is given by t2 divided by t1 is equal to t3 divided by t2. t2 is x plus 1, and t1 is x minus 1. Therefore we have x plus 1, divided by x minus 1 on the left-hand side of the equation. t3 is 2x plus 2, and t2 is x plus 1. Therefore we have 2x plus 2, divided by x plus 1 on the right-hand side of the equation. Now, let's cross-multiply. We now have x plus 1 in brackets times x plus 1 in brackets is equal to 2x plus 2 in brackets times x minus 1 in brackets. We can now use the FOIL method to expand both sides of the equation. If we look at the right-hand side of the equation, minus 2x and 2x cancel each other. And on the left, x plus x is 2x. So we now have x squared, plus 2x, plus 1 on the left-hand side. And 2x squared minus 2 on the right-hand side. Now, let's look at the like terms and group them on the right-hand side of the equation. 2x squared minus x squared is equal to x squared. If we move 2x to the right-hand side, it becomes minus 2x. And minus 2, minus 1, is minus 3. Now, let's factorize the trinomial. X plus 1 in brackets, times x minus 3 in brackets is equal to 0. Therefore, x is equal to minus 1, or x is equal to 3. Since we have two values of x, we will have to check their validity. The values given to us are x minus 1, x plus 1, and 2x plus 2. When x is minus 1, we have minus 1 minus 1, minus 1 plus 1, and 2 times minus 1 plus 2 as the first three terms. And their values are minus 2, 0, and 0. Looking at these values, t2 and t3 are equal to 0. But r cannot be equal to 0. Therefore, x cannot be equal to minus 1. So we can say that x is not equal to minus 1. Now let's write down the values of the first three terms of the sequence. When x is equal to 3, we have 3 minus 1, 3 plus 1, and 2 times 3 plus 2 as the first three terms. Therefore, the values of the first three terms of the sequence are 2, 4, and 8. We have reached the end of the lesson. Please like and subscribe if you've enjoyed this lesson, learned something new, or if you want us to continue making these awesome videos. Let us know which topic you are struggling with the most in the comment section so that we can get you sorted. Also follow us on Twitter, Facebook, LinkedIn, and Instagram so that you can stay updated with regards to all things mathematics. Thanks for watching. Goodbye.